Okay, so year 10. What we're going to do today is have a look at simplifying surds. So this is something you'd have done back in year 9 and probably a little bit in year 10. But it's something you need to be able to do for your GCSE, and it's really easy to forget. So here we've got a surd, we've got root 12. We need to simplify it. Now to simplify a surd, you look for a factor that is a square number. So your square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. So we look for a factor of 12 that is also a squared number. We ignore 1 just because 1 isn't the number used to us. So then we look at this list and we go, oh look, 4 is a factor of 12 and 4 is also a squared number. So because of that, root 12 can be split into root 4 times root 3, because 4 times 3 is 12, so root 4 times root 3 is root 12. Then after that, what is the square root of 4? The square root of the number 4 is 2. And so our final answer is 2 times root 3, which we simply write as 2 root 3. That is it. Okay, I know this is tricky, but that is all you need to do. So let's try a second one. Let's try simplify root 54. So all we do now is we go 54 and we need to find a factor of 54 that is also a squared number. So have a look through. 4 is a factor, no it's not. Ah, right, 9 is a factor of 54 because 9 times 6 is 54. So root 54 can be written as root 9 times root 6. Then after that, what is the square root of 9? What times what is 9? Well, that's 3. The square root of 9 is 3. So our final answer is 3 root 6. And that's it. Okay? We'll try a slightly more difficult one now, and then we're going to look at some reverse problems. So it's a tiny bit harder. We are going to have 3 root 80. So here we've got to simplify 3 root 80. Now first of all, what you just need to have clear in your head is that 3 root 80 means 3 times root 80. So almost ignore that 3 to start off with and just look at the root 80. Can we find a factor of 80 that is also a squared number? So I go through and have a look at my list. Well, 4 is a factor of 80, so that works, but let's keep looking because 9 is not a factor. Now 16 is also a factor. It is quicker if you can find the biggest possible square number that is a factor. So here that's 16. So root 80 splits into root 16 times root 5, because 16 times 5 is 80. Remembering the whole thing is being times by 3. Then after that, well, what is root 16? What is the square root of 16? And that's 4. So we get 3 times 4 times root 5. And then 3 times 4 times root 5 is simply 12 root 5. That is all there is to simplifying surds. So that's one of the things that you're going to be having a go at practicing today. Okay, so then part 2, year 10. This question here, express as a single square root. Now this is more unusual. I wouldn't normally expect to see this in a GCSE paper, but it's a really good type of question for really testing your understanding. So here we've got 3 root 2 and we want to write it as a single square root. That means we want to write this as just root something. So we're going to sort of do the opposite to what we just did in these first examples. So with those first examples, we found the factor was a squared number, blah, 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 blah. So now we're going to do the opposite. So we're going to think, well, what is 3 squared? Or how else can I write 3 like this? This 3 can also be written as root 9, because 3 squared is 9 and root 9 is 3. So I can write 3 as root 9. So then rather than writing 3 root 2, I can write root 9 times root 2. And then root 9 times root 2 is simply root 18. So that's how we can express something as a single surd, or as a single square root. As a second example of that then, let's say we had 5 root 7, and we want to write that as a single square root, like the question said, a single square root. So what we're going to do is we're going to leave our root 7 bit alone, and we are going to think, well, how else can I write 5? If I had to write 5 with a square root symbol, well, it would be root 25. Because 5 squared is 25, so root 25 is 5. These two bits are the same. So then after that, instead of 5 root 7, we've got root 25 times root 7, to which the answer is simply, well, 20 times 7 is 140. 5 times 7 is 35. So you add these together and get root 175. Okay, and so that's that. As I say, it's a more unusual type of question, but it is going to come up in the work you're doing today. So hopefully that will help you be able to do it. Good luck. As ever, please email me with any questions.